Okay, and we're back. Just a couple things I want to mention here. We're just doing practice with multiplying polynomials, and just some things that might be helpful to you. This is optional, but one thing that's a little bit easier when you're doing this kind of simplification. When you look at this one right here, even though it was quite long, what made it nice and easy to simplify after you did the multiplication was that all the like terms were lined up along the diagonal. That doesn't always work out that way, but there's some things you can do to always ensure that that does happen for you to make your life a little bit easier. So one of the things that you can do is before you start setting up your array, you can arrange whatever polynomials you have in a standard form, which means it's a descending order of power. So if it's quadratic, you do a squared term followed by the x term followed by the constant. And the other thing that you could do is you could use a placeholder. So let's just say, for example, I give you x squared plus 4 times x minus 3. So when you do the array, you could set this up as a 2 by 2 array because there's two terms in each, but it might become a little bit trickier to sort of find all your like terms. What you could do as an option is add a 0x in here. So that's what we call being a placeholder. And now you would have three terms here, so your array would have x squared 0x and plus 4. And then x minus 3 here. Now, if you're doing that, I know it looks like it's creating more work, but if you do that, what's going to happen is you're going to have all your like powers like terms aligning along the diagonals. So you'd have x cubed here, x squared terms along here, x terms along here, and constants down here. And again, if you're okay with identifying your like terms, if it's not along a diagonal, that's fine. You don't have to do this, but it's just an option that's there. Okay, so I want you to just give this one a try. So we got two-term polynomial and then a three-term polynomial. So this is one of those ones where you have two options. You could include that extra 0x term because there is no x term in this first one, even though it's quadratic. Or you could just do it normally. So I'm going to do it normally. So I have two terms here, 3x squared plus 1, three terms up here, the 2x squared minus 5x minus 7. I'm just going to fill in each term using multiplication. So the one thing with this, you just got to be very, very careful. It's really easy to rush through this and make a little algebra mistake. So make sure you're adding the exponents on x when you're multiplying variables. Make sure you're watching your negative signs. And again, all these just being filled in with multiplication. So when I'm finished, look for my like terms. I get 6x to the fourth. Looks like that's my only x cubed term, so minus 15x cubed. I got x squared terms here and here. And there I go. There I have it. Okay, one last example. So a couple things to watch out for here. I'll give you a second to try it on your own and work through the algebra. I just want to show you a couple things here. One thing to watch out for here, you got 3x plus 5 all squared. One of the most common math errors I see from high school students is seeing something like this. They're going to tell me that 3x plus 5 squared, they see the square, they just think, okay, I'm just going to square the 3x. So 3x all squared is 9x squared. And 5 squared is 25. This is what I would see very, very commonly from kids, and unfortunately it is completely wrong. So one thing to remember here, you got to be careful, because when something is squared, it means it's multiplied by itself, right? 5 squared is 5 times 5. So if you have 3x plus 5 all squared, that is the same thing as 3x plus 5 times 3x plus 5. Okay, so that binomial is being multiplied by itself. So if you want to actually multiply these together, you have to use distributive property or use an array. And because you're going to be missing a term if you just assume that it's the first term squared and the second term squared, because that's not going to be the case. So you just got to be very, very careful about that and avoid making that mistake. Okay, so what you're going to have to also watch out for here, we've got two multiplications here, right? So we have to multiply 3x plus 5 with a 3x plus 5. We also have the 2x minus 3 and the 4x plus 5. That's two different multiplications that we have to do. And then we have subtraction separating them. So once we expand this out and expand this out, we're going to be subtracting one from the other. So take a minute and try that out, and push play when you're ready to see the answer. Alright, here's our answer. So I didn't show the array, but I expanded this out using an array, got 9x squared plus 30x plus 25. Expanded this one out, got 8x. Oh, slight little mistake here. I wrote a cubed here. That should actually be a squared. Okay, and that should be a squared down here. Okay, so I got 8x squared minus 2x minus 15. Another thing to watch out for here, notice that this subtraction here applies to this whole thing. So your result here, your 8x squared minus 2x minus 15, that whole thing's being subtracted from my original polynomial over here. So you got to be very, very careful here. Keep your second multiplication in brackets, because in your next line here, you're actually distributing this minus sign to everything inside that second polynomial. Okay, just be very, very careful with that. So now it's minus 8x squared plus 2x plus 15. So just watch out for those little signs there. Okay. Very, very easy mistake to make. So then once you have that, you can collect your like terms, and you get x squared plus 32x plus 40. Okay, and again, the whole idea behind doing this, it's our end result is for all these questions is something in standard form. So right now we're looking at something in factored form, like for example, one like this right here, and when we're finished, our final answer is in standard form. So let's just see. Once we can move freely between those two forms, we can get different information about the parabola without too much effort. So it takes a while to get there, but this is just one way of moving from factored form into standard form. So that's it. That's all. There's some practice here in your textbook. Hopefully it goes well. It's a pretty important skill to be able to do this not only accurately, but eventually do it relatively quickly as well. So it does take a lot of practice, but once you've done a bunch, it'll make a lot more sense. Okay, thanks a lot. Cheers.